The James Webb Space Telescope captures distant and ancient secrets of the universe with its unparalleled infrared vision. Yet, some of the most captivating cosmic mysteries lie much closer to home, on the Moon. While we might assume our celestial companion has been thoroughly decoded, the reality is far from it. Fundamental questions about the Moon's formation remain unresolved. Intriguingly, gravity field measurements reveal a colossal structure hidden on the Moon's far side, fueling a mix of scientific theories and wild speculations. How the Moon came into existence is still debated. Was it formed from debris after a massive collision between Earth and another celestial body, or did it emerge through an alternative cosmic process? The answers remain elusive, leaving room for continuous exploration. One prevailing theory suggests that the Moon formed after a Mars-sized body, often called Theia, collided with the early Earth. This cataclysmic impact would have ejected material into space, which coalesced into the Moon. However, variations in lunar isotopic compositions, as well as its differing internal structure compared to Earth's, leave researchers puzzled. Alternative theories, such as co-accretion or capture, have their own shortcomings, adding to the mystery. One of the Moon's most intriguing features is its tidal locking with Earth, which causes the same side to always face us. Initially, the Moon spun much faster, but Earth's gravitational pull gradually slowed its rotation to match its orbit. This synchronization has fueled centuries of speculation about what lies on the hidden far side, inaccessible to human eyes for thousands of years. Despite its name, the dark side of the Moon isn't permanently dark. Like the near side, it experiences the same phases of illumination from the Sun, only in reverse order. During a new moon, for example, the far side is bathed in sunlight, while during a full moon, it falls into shadow. The far side of the Moon remained hidden from human view until 1959, when the Soviet Luna 3 probe sent back the first images. These pictures revealed stark differences between the two hemispheres. Unlike the near side, characterized by vast plains of basaltic lava called Maria, the far side is dominated by rugged highlands and far fewer Maria. This distinction has since sparked questions about the Moon's geological history and evolution. In recent years, one of the most compelling discoveries has been the identification of a massive anomaly beneath the Moon's far side. This structure lies hidden beneath the South Pole-Aitken Basin, the largest preserved impact crater in the solar system. Spanning over 2,000 kilometers in diameter, the basin represents an ancient scar from a colossal collision estimated to have occurred 4.3 billion years ago. Gravity field measurements by NASA's Gravity Recovery and Interior Laboratory, GRAIL, mission unveiled a dense mass buried hundreds of kilometers beneath the basin. This anomaly is estimated to weigh an astonishing 2.18 quadrillion tons, making it one of the largest known structures of its kind. To put it into perspective, it's about 5 times the mass of the Hawaiian island of Oahu, buried deep within the lunar mantle. Such a discovery inevitably spawns a wide range of interpretations. Some internet theories propose that the Moon is an artificial structure, and the anomaly might be a remnant of an ancient lunar civilization or an alien base. However, mainstream scientists lean toward more natural explanations. The prevailing hypothesis suggests the dense mass could be the metallic core of the asteroid that formed the South Pole-Aitken Basin. Simulations indicate that during the impact, the asteroid's iron-nickel core could have penetrated deep into the Moon's mantle without fully merging with its core. Alternatively, the mass anomaly might consist of dense oxides left over from the cooling of a primordial lunar magma ocean. The stark contrast between the near and far sides of the Moon extends beyond surface features. Scientists have discovered that the far side's crust is significantly thicker than the near sides. This discrepancy likely influenced volcanic activity on the Moon, as the thinner crust on the near side made it easier for molten rock to reach the surface and form Maria. Adding to the mystery, the near side is enriched with radioactive elements such as thorium, potassium, and rare earth elements. This region, known as the Procellarum Krep terrain, represents an anomaly in the Moon's otherwise uniform composition. Researchers suspect that these differences may be linked to the same cataclysmic event that created the South Pole-Aitken Basin. Matt Jones and his colleagues at Brown University have used geophysical models to investigate how the impact that created the South Pole-Aitken Basin affected the Moon's interior. Their simulations suggest that the collision unleashed a surge of heat that propagated through the Moon's mantle, creating a thermal anomaly on the opposite side. This heat surge likely played a crucial role in shaping the near side's unique geology. It may have redistributed heat-producing elements and spurred volcanic activity that formed the Maria. Over time, mantle convection brought titanium-rich magma to the surface, creating the Moon's characteristic dark plains. The volcanic activity that shaped the near side of the Moon likely began around 200 million years after the South Pole-Aitken impact. The most intense period of Maria formation occurred 300 to 500 million years later. These eruptions poured vast quantities of basaltic lava onto the surface, creating the dark plains visible to the naked eye from Earth. The interplay of radioactive heating and mantle convection likely sustained this volcanic activity for hundreds of millions of years. Meanwhile, the far side, with its thicker crust and lower concentrations of heat-producing elements, remained relatively inactive. The South Pole-Aitken Basin serves as a natural laboratory for understanding the Moon's early history. Its massive size and ancient age make it a window into the processes that shaped the Moon's crust and mantle. Future missions, both robotic and human, could provide valuable insights into the basin's composition and the origin of the mass anomaly. In January 2019, China's Chang'e 4 mission became the first spacecraft to land on the Moon's far side, paving the way for unprecedented exploration. Equipped with a suite of scientific instruments, the rover Yutu-2 has been studying the basin's geology, revealing clues about the Moon's formation and evolution. The data collected by Chang'e 4 has already enriched our understanding of the lunar surface. However, much remains to be uncovered, particularly regarding the subsurface structure and its connection to the Moon's broader geological history. While modern technology has provided incredible insights, some mysteries of the Moon persist. Why, for example, does the Moon have such a low density compared to Earth? And what explains the unusual isotopic similarities between the two bodies? These questions point to a complex and dynamic history that scientists are only beginning to unravel. The Moon's proximity and rich scientific potential make it an ideal target for future exploration. NASA's Artemis program aims to establish a sustainable human presence on the Moon, potentially unlocking new discoveries about its interior, surface, and interaction with Earth. Similarly, international collaborations and private initiatives promise to accelerate our understanding of this enigmatic world. Beyond its scientific significance, the Moon holds a unique place in human culture. For centuries, it has inspired myths, legends, and artistic expression. The far side, in particular, has often been a canvas for the imagination, representing the unknown and the mysterious. Modern exploration has demystified much of the Moon, yet its allure remains undiminished. As we uncover its secrets, we also deepen our connection to this celestial neighbor, bridging the gap between ancient wonder and cutting-edge science. The Moon is no longer just a symbol of mystery, it is a gateway to understanding the broader cosmos. Each discovery, from the hidden mass on the far side to the remnants of ancient volcanic activity, adds a piece to the puzzle of our solar system's history. As we stand on the cusp of a new era of lunar exploration, the Moon continues to captivate us with its duality, its light and shadow, its near side and far side, its known and unknown. The journey to uncover its secrets is far from over, promising revelations that will reshape our understanding of the universe and our place within it. How the Moon came into existence is still debated. Was it formed from debris after a massive collision between Earth and another celestial body, or did it emerge through an alternative cosmic process? The answers remain elusive, leaving room for continuous exploration. One prevailing theory suggests that the Moon formed after a Mars-sized body, often called Theia, collided with the early Earth. This cataclysmic impact would have ejected material into space, which coalesced into the Moon. However, variations in lunar isotopic compositions, as well as its differing internal structure compared to Earth's, leave researchers puzzled. Alternative theories, such as co-accretion or capture, have their own shortcomings, adding to the mystery. One of the Moon's most intriguing features is its tidal locking with Earth, which causes the same side to always face us. Initially, the Moon spun much faster, but Earth's gravitational pull gradually slowed its rotation to match its orbit. This synchronization has fueled centuries of speculation about what lies on the hidden far side, inaccessible to human eyes for thousands of years. Despite its name, the dark side of the Moon isn't permanently dark. Like the near side, it experiences the same phases of illumination from the Sun, only in reverse order. During a new moon, for example, the far side is bathed in sunlight, while during a full moon, it falls into shadow. Thanks for watching. If you love exploring cosmic mysteries, don't forget to like, comment, and subscribe to Space Lab. Stay tuned for more incredible discoveries. See you next time.